Confidence, there's the word. That's what we want. People to be confident with their program, and when they put it out to machine, and we're going to reduce those collision risks.
Today in the MTD CNC Tech Corner, I have Paul from Tebis, and we're going to be talking about the digital twin and virtual machine side of the Tebis software. So, Paul, let's start with the digital twin. What can you tell me about it?
Okay, so the digital twin, most people think of the digital twin as just being about machines. And of course, this is a very big part of digital twin, but it's also about the whole machining environment in Tebis. So in Tebis, where we build in your working practices into the software through our libraries, like your cutting tools with your speeds, feeds, ramping feed rates, plunging feed rates, step over feed rates, maybe recommended step overs, depths of cut, and your cooling. All this is built into the tool library. Could be your clamping devices, what machines you've got, even your processors, if you like, for machining certain types of job through automation and templates. All of these can be built into the software to give you that complete manufacturing digital twin environment. But of course, you know, today we're talking about the digital twin of the virtual machine. And in Tebis, we're machine-orientated program, and the virtual machine is a really important part of this process.
So, Paul, why is all this so important?
Okay, it's really important because what we don't want to have is a situation where we program a job and then we find out afterwards that actually when I try to run this on the machine, that the machine kinematics don't support the operation I'm doing. Or then we find that there's a rework loop that needs doing and we have to go all the way back to the CAM side of things, and then we have to restart it all again. Now with Tebis in the virtual machine, we build, if you like, the kinematics into the machine right from the start, and you use this machine while you're programming. As I said, it's machine-orientated programming, so first we can choose the machine that we're going to use. And if we've built all of the rotational limits into the machines, could even be the linear limits, basically the complete machine environment, then while I'm programming, I'm understanding from Tebis's feedback if I can actually achieve what I want to achieve through my programming process. So we're going to cut out all of this rework loop, if you like, right from the start, and we know we've got good programs to send to the machine right from the moment we're doing the program.
Because there's a lot of companies out there that have a programmer who's away from the machines. They're not always stood at the machine control. So like I said, if the machine control doesn't work because you're out of limits or something, it's going to be a ball ache going back and forth. So to make it easier and to make it quicker, now let's talk about virtual machine, because what's the importance and what's the benefits of using a virtual machine for machining parts?
Okay, so to start with, as I said, it's about understanding the kinematics from the machine from the moment that you start programming. But as part of that, one is the kinematics for the program, but the other is the safety of this. And the Tebis solution is scalable. So with it, when you purchase a post-processor, you get a virtual machine with it. And this could be from, if you like, our entry level, which is a catalog machine, which is, if you like, maybe it will be close to your machine. It's off the shelf. Okay, and we've got a library of probably one of the largest libraries in CAM providers of over 9,000 different machines. And this could be scaled up through from that catalog machine to a fully verified machine, where we come in and we perform a service of measurement on the machine. We put all of the machine macros into the virtual machine, such as could be the tool change, a machine head change, maybe a particular macro that the customer has which he wants incorporated, which he likes to use. And we build all of these things in like with the look ahead of the machine, what the rapid rate is. So we're getting 95% accurate machining times as well from this at its highest level. And also, you know, what we're simulating as well with that is, as I said, the tool changes, the head changes, but it could be even the traverse from the end of one program to the start of the next. And this is really important about how we're getting around the job to avoid the collision in between programs as well. So all of this is really important for safety and reducing any collision risk. To use if you like a phrase, this is true simulation and not an animation. to start with. So
I
we
like
know.
that phrase.
Thank you. So we know that because of the kinematics built in, we know we're getting the right feedback of the machine. And to start with, if you like, what makes it different is we use the machine at 3 stages. And one is at, if you like, the planning stage. So we're setting the job upon the machine. Does it fit? Okay, is the part too big for the machine, or where is the optimal position for the part on the machine? Can I get round it if I'm doing angular movements? Is the part clamped high enough, etc.? Where is the clamping device? So all of these things are important. And then we use it in the programming stage, as we talked about. But in the programming stage, then we're understanding the kinematics of the machine, but also we're able to take into consideration with our collision avoidance technology, even the machine head. So this is
I think that demonstrates it perfectly.
As you can see here. And this is really important because most software, they take into account the tool, the shank, maybe the tool holder. But if I'm in a cavity, what about the spindle? Yeah, so Tebis does this as well for you. Yeah, and it's able to reduce the toolpath, employ a 5-axis movement to avoid a collision, to actually give us a good program with this. And then we're using it for a safety of a final collision check where we can check against a complete machine. And we can even do a dynamic check with this through the complete stop checking as well from start to finish of the part. And as I mentioned, get complete accurate machining times out. And if we're using it, as you mentioned, for robots, I can check for maybe a conflict, such as a singularity, or and use these robots for other niche, if you like, activities such as polishing, maybe, yeah? Or, obviously we want the milling techniques like trimming and things like that, but polishing is something that could be used for. And also if we're looking at turning and turn mill, really complex machines, let's be honest, yeah? But, understanding the part transfer and having collision checking between this. As you saw there, the complete turret should be collision checked as well. And we can do all of this in Tebis, and we can support many, many machines, by doing this, yeah.
So safety, collision checks, like you said, robot here, for not just the machine, not just the spindle, but for the whole head.
Yes.
Part transfer, turrets, everything is in there to
Yes.
make sure when you press that green button, you are 100% confident that what you see on here is what you're going to get out the other side.
Confidence, there's the word. That's what we want. People to be confident with their programmer when they put it out to machine, and we're going to reduce those collision risks.